Welcome to the Founders of Web3 series by Outlier Ventures and me, your host, Jamie Burke. Together we're going to meet the entrepreneurs, their backers and the leading policymakers that are shaping Web3. Together we're going to try to define what is Web3, explore its nuances and understand the mission and purpose that drive its founders. If you enjoy what you hear, please do subscribe, rate and share your feedback to help us reach as many people as possible with the important mission that is Web3. Okay, so today I'm really happy to welcome a guest from Enigma, one of the co-founders, Can Kisagun. He and Enigma are somebody that we at Outlier have been working with for several months now on some really interesting projects. So it's really exciting to have you here today to talk through Enigma and your journey as a founder.
Very exciting to be here, Jamie.
So to do a quick summary of your background, like your co-founder, Guy Ziskind, you both spent some time at MIT, albeit you were at Sloan and he was at MIT Media Lab. So your own background was at Sloan and prior to that Northwestern, where you did a Bachelor of Science in Industrial Engineering. You also spent some time at McKinsey working in Turkish capital markets and media, and you are kind of a second-time founder, I believe. Previous project was Street Dust and Exim-Chain.
Yes, that covers, I don't know, a 10-year period pretty concisely.
And given the name and the connection with McKinsey to Turkish markets, I assume you are Turkish?
Yes. I'm from Istanbul. I grew up there and spent all my time until high school. Then went to school in the US, came back briefly, and then now I'm living in the US again.
On the West Coast, right?
Yeah, San Francisco right now.
Okay. So as I understand it, the kind of origin story of Enigma was that you met Guy at the Bitcoin Club at MIT, where he was teaching a class, and you began to discuss and explore possibilities, ultimately leading into Enigma.
So actually, Enigma was Guy's research project. When I met Guy, he was already working on Enigma, and I met him through the MIT Bitcoin circles. He was, I think, presenting his work in a Sloan class. And then this was spring of 2015. The Enigma white paper came out, and I'm not an author in that. Guy's primarily the author of that in, I would say, the summer of 15. And then Guy was teaching this class in spring of our second year. And both me and my colleague Tor were in that class. And then after that, we just kept in touch, stayed in connection. We both graduated in 2016 and he went on to do Enigma. I had a 6-month period where I was working on this project called Exim-Chain. And then eventually our roads crossed again in 2017.
So it's really interesting, Enigma as this kind of spin out from MIT. Obviously, that's a particular type of startup. I know in the crypto world, there's certainly in the US, and from an investor perspective, a kind of almost preference for spin outs, very technical teams spinning out of these kind of top tier Ivy League campuses. As a spin out from academia, what do you think is different about that journey, and how did you find you were perceived by investors and kind of customers when you first came out to market?
Yeah, so we had 2 major rounds of fundraising. One was in the summer of 2016 before I was fully involved, and I think at that point Enigma was more perceived as an academic project from more traditional venture capital firms. And then there's a second part which I was more involved in, which is the the token sale part. At that point, I think it was beneficial for us because we had been doing a lot of work in the blockchain space as a project with academic background. So that was helpful. And in the first round, I'm not sure, I wasn't part of those conversations, but I do remember that when I first joined and we were working on, when I was working on business development part of things, that we had this cool technology that we would go and tell everyone about. But at the time, people didn't really know what to do with it. So I think in our case, it's fair to say that in our early days, especially when we were dealing with enterprise, we were this, kind of a hammer looking for a nail situation, as most people criticize, like, blockchain.
A very common theme.
Yeah.
And I mean, I guess, so we talk a little bit about the innovation itself, and obviously the way that the project describes itself has evolved, presumably along that journey of something that is, I guess, one of the challenges when you solve a fundamental technical problem and it is, generalized or generalizable. The problem is, how do you then translate that to be relevant to an industry or a particular use case? But generally, is it fair to summarize the work you're doing as a blockchain-based protocol specializing in privacy technologies that allow this kind of end-to-end scalable dApps? And at the heart of that, the innovation is what you refer to as secret contracts. So that is allowing people, companies to perform privacy-preserving computation and to enable this secure data sharing.
Yeah, that's an accurate description. And I think tying back to your previous question, that's exactly what we do. But when we first came out with this, like, for example, people would have privacy and and performance or usability usually come at some trade-off. And like one problem that we initially had was, like, people would expect us to do highly performant things like running like a Hadoop database with like privacy preserving techniques like multiparty computation, and that was like not possible. Still today is not possible. So I think when you talk about performance and generalizability, early on we had expectations from enterprise partners that we were working with to have extremely high performance requirements, but also have privacy, which is in the software privacy world is somewhat unheard of.
And so there's this kind of trade-off that the world faces at the moment in almost every domain, really, which is it's kind of either privacy or usability, and none more environment is that true than blockchain. It'd be maybe worth just explaining the multi-party computation piece. So I know you said that initially you kind of went down that path when you were looking for taking the product to market, trying to translate it into, I guess, a language and a use case that people understood, a pain point. Initially, when you were speaking to enterprise, it was around multi-party computation. Could you maybe explain what multi-party computation is and how your approach with secret contracts is different?
Multi-party computation is a software-based encryption method, similar to homomorphic encryption, where technically what you do is, say I have a piece of data, we divide this data to multiple pieces and send it across the network. And in order for that data to become relevant, by that I mean using a computation or be displayed, we would need, say, 50 of the 100 participants in the network, obviously numbers are illustrative, to come together and perform this computation. So that's like the basic of it. That's what multi-party computation means. It's similar to Shamir secret sharing that people in the crypto world sometimes use around custody applications. But the whole idea is one party alone cannot see or cannot leak the data. So it has to be a group effort to make the encrypted data be usable.
And what was broken about multi-party computation that needed a different approach?
The problem is scaling of such software cryptographic techniques. I think one way to look at it is one can either choose a specific application and work really hard to optimize that. So if you look into what Zcash is doing with zero knowledge circuits is, they have a specific use case, and then they're improving on that, but it's just sending and receiving coins in a privacy preserving manner. So in our case, since we're looking at computations, which is arguably a larger domain than just sending and receiving funds, it's really hard to identify one specific use case and really get performant in that. We were looking a lot of in fraud detection kind of use cases where company A has some data. If they merge it with company B, then they can do more effective fraud detection, but they can't because of the sensitive nature of the data right now. And so that was our use case when we were having our enterprise focus. But still, even with that, the computations that were involved, I don't want to get too technical, but required saving some name in memory and propagating that across every comparison. So just to give you an idea, we were at the time when we were doing MPC work, this is first half of 2017, we were much more performant than all academic papers out there, maybe an order of magnitude, but still something doing a linear regression would take us maybe I don't want to give a wrong number, but maybe 10,000 times slower than doing this with plain text. And when you have enterprise customers who need to move fast, etc., the scale issue became a big limitation for us.
And so that's interesting. In an academic realm or theoretical realm, you'd solve the problem. And maybe we could just talk a little bit about what was different, how secret contracts solve for those problems in approaches around multi-party computation. But then you had to somehow scale that in a commercial setting. So maybe we could talk about what's different about the approach, how that solves for it, and then how you've gone about scaling that in a commercial environment.
We have changed. So our mission has always been, the goal to push privacy preserving computation for better data security and better privacy. And we're still working on that mission, but what has changed is how we achieve that. So instead of doing multi-party computation, which is a software-based encryption method, we have taken a hardware approach, which has its trade-off. This hardware approach is called a trusted execution environment. This is similar to the fingerprint readers in our phones, in that computers or servers have a separate enclave, separate processor that is only accessible by that enclave alone. So it's almost like when you send your fingerprint to your iPhone, your fingerprint never goes to Apple, but your fingerprint is only processed within this enclave. This technology also exists on Intel chips that have been released in the last 4 years. So what we have done as a change in direction is we've learned to use this chip and built an operating system on these chips such that a user can encrypt data locally on their device, send it to this enclave in encrypted form. It's only decrypted inside the enclave, and the security guarantees of the enclave ensure that the private key that can decrypt this input is generated inside the enclave and cannot be leaked. So that was a change in approach. And obviously, when you do this kind of change in approach, the computations become much faster. You are now closer to the performance you get when you run computations on plain text data.
Right. And so this is this kind of off-chain computation, and the secret smart contracts are the things that then link what happens off-chain, where you can get higher performance, with what happens on-chain. Can you kind of talk through that a little bit more?
Yeah. So what I described as the trusted execution environment is a way to do privacy preserving computations. This can work as a single server. This can work as a blockchain. So what we've done with the Enigma blockchain, we have a network of nodes that run these trusted execution environments, And that's how you become a node. So it is not like an off-chain solution. This is part of our chain. It's just that the nodes need the special hardware to participate in the network.
Okay, understood. And I know that you've been working linked to this around governance and the idea that smart contracts and some of the work and problems you've been solving for can also be applied to governance issues more generally in the decentralized space, in particular auctions, and the idea that you could have decentralized exchanges for computation, data computation, and potentially even dark pools as well, right?
Yeah, so there are a couple of interesting applications. I think one thing that we have figured out as we dive into building this blockchain was privacy is not only relevant for handling sensitive data and opening or allowing new applications to be implemented into the blockchain ecosystem, but it also creates significant usability gains to existing applications that we use in the decentralized world today. Some of these you touched upon. For example, things like governance. It's important to keep the anonymity of the votes. So at least during the time of tallying, in order to make sure that people are not discouraged from voting if they see the tally going in one direction. So the solution space that we had seen revolved around using this concept of a commit reveal, which means as a user, you would first commit your vote. You would take the hash of your vote and commit to it, so no one could understand what your commitment is. And at a later time, you would reveal your commit saying, hey, I actually had voted yes, and here's my proof to it. And that's how voting was supposed to be done. And if you think about user experience, you don't really want to go and do a two-time interaction. Actually, we've heard from projects working on this that that issues of people committing their votes but forgetting to reveal them, etc., etc. So one thing that we hope to bring to the governance part is you can have using these secret contracts. You can have a single interaction from the user. You can cast your encrypted vote to the Enigma network, and when the time comes, the network can automatically decrypt your vote, have the tally, and show the results, 60 yes, 40 no, whatever, to the entire network without revealing user's vote at any time. So what we thought was let's focus on privacy and anonymity on the vote. We found that actually the value we brought was more on the usability side, because at this point, decentralized governance don't really involve very, very, critical votes like your political orientation or whatnot. So that was one area where, we see that privacy and usability, especially in the Web3 space, go hand in hand. And there many more applications like this. This applies to the gaming space a lot. We were in ETH Waterloo, I believe 6 months ago, and there's a team who was doing contract work for Cheese Wizards. I'm not sure if you remember this game, but it was by Dapper Labs, the folks who were behind CryptoKitties, and they built Cheese Wizards, which is a glorified rock paper scissors game that you would play with wizards. And their implementation, because when you're playing rock paper scissors, if you go first and I know what your move is, and I can easily make the winning move. So they also refer to this commit and reveal technique where you would choose your moves, you would submit them, and the other part would choose their moves, submit them both in commitment form. And then once commitments are submitted, each player would have to reveal. And then, you would calculate the winner, and a single game of rock, paper, scissors could take up to 4 hours or so. So a team there took the game logic, built it with Enigma, that, removed the requirement to do this commit reveal, and they were able to cut the game length by at least 50%, which means more people get to play, there's more activity, and it's it's helpful for this game. So these things actually go hand in hand a lot.
So you guys have also been working on transactional privacy, on-chain transactional privacy. Could you tell us more about that?
Sure. We call our transactional privacy efforts salads. That's the name of the product. We call it salad because privacy is healthy. And salad is also another great example of where privacy can bring usability to blockchain applications. What we do is slightly different than the zero knowledge implementations, which require a user to create a proof and then verify that they have that proof in order to mix their funds between address A and address B. So again, this is like a two-step process, similar to Comet Reveal. We replace that with a single user interaction using our network. So what the user does is the user would send in the recipient address that they want to see the funds go to into a secret contract. And the secret contract would take in addresses from, say, 20 users, randomize them, and then submits those 20 randomized addresses to the contract that's holding the deposits. And what this effectively means for the user is you do one transaction and your funds are mixed. And this has been extremely helpful for us in pushing the conversation with Web3 wallets like MetaMask and my Ether wallets, because our way of creating transactional privacy matches the way their users are used to sending funds. Again, this is going to be a high focus area for us going forward.
So I know when we're talking about a lot of this stuff, it might seem quite navel gazing in that these are problems, we're solving for problems that are very niche, very particular to Web3 and the crypto space, and the rest of the world doesn't really care about. But clearly these are foundational problems that are critical to solve in the Web3 space and around decentralized governance. So I know you guys have been exploring a number of different domains to apply these technologies in. On the one hand, you talk about big impact research areas, how you can allow industries to begin to share data, to run computation, and presumably to share in the benefits of that. And then equally, you've also been looking at how you could begin to apply these technologies to the world as it is today in a kind of Web 2 context. So what you might do with Facebook data. So maybe we first kind of spend a bit of time talking about these big impact research areas. I know that Corona is very topical at the moment, and that's something you've been actively participating in.
Yeah, no, I think so. Before diving into the details, I think one thing that we can say is like either Web3 or Web2, there is there is a trust model, and what changes in Web3 is a trust model. So like a very high level and basic example is we can think about what Bitcoin has brought is taking the role of a bank, which would process me sending you money and distribute that to thousands of people, anyone who wants to run a Bitcoin node. And what that means is the trust model changes in that I used to trust the bank to do this, and also with my data. Now I need to trust the nodes to do what they're supposed to do, and there are economic incentives built into it for them to be good actors. And then you also have to trust these random people on the internet with your data. I guess where we see our work can bring value is around this trust factor. Who do we trust with our data, and to what extent? Now looking into some of the data and privacy issues that we've been, I guess, seeing again and again in the past couple of years in the Web2 space. Like we know that our data has been used without our consent in ways that we do not condone. Like I think Facebook is a great example of that, and I don't think that 99% of us are aware of how, say, our cell phone location data is being used. So there is a fundamental issue about, okay, like how do we use the data, who gets access to it, is it being used in the right way? And this applies to, either institutions that control our data, from like a user's data being controlled by other institutions, but it also is, is interesting when you have two institutions who, can benefit from sharing data. So I think this is an interesting point. Like, how do we think about security of our data? And the Corona example you gave kind of fits, this realm where there is a lot of contact tracing, or I would say digital contact tracing efforts that are being proposed with different privacy features. And we have lately volunteered to take some of our expertise in privacy preserving computation to build a better, a more privacy preserving way of doing contact tracing. We are trying to work with some applications that have location data to run these analyses. What we're trying to do there is not blockchain based, but we have a server that users can share their location history and diagnosis status in an encrypted way, and consider this API as a secure data storage and computation platform where your data is stored. And once you and other people like yourself have contributed data to this API, the API, without our access or our control, can decrypt that data, run computations on it, and give you insights. In the context of SafeTrace, which is the name of our effort, you get to learn as an individual whether you've been in close proximity with someone, or you also get some, let's say, more macro analysis on how people who have tested positive have been moving around the city. Say you need to go do grocery shopping, you can see which grocery store has lower risk based on people's movement. And all this can be done without revealing any user privacy. We were encouraged to do this because we saw there were government initiated efforts, like say in Israel, that does this and has zero user privacy. So we're like, okay, we can actually build this using what we have and provide better privacy guarantees.
So this is the big thing at the moment. I mean, it's very zeitgeist in that everybody's talking about this trade-off with privacy if we want to be able to respond to contain Corona. Is this approach that you're talking about something that would augment, say, what Google and Facebook are working on, or does it provide a distinct alternative?
I think it's Google and Apple. They just released something this past Friday. So it's actually a different approach to it. I think it's really good that you raised it. The Google and Apple approach has a different security model. I think it's very clean in that you and I, say we both have our Bluetooth devices. If we're in some close proximity, your device sends your device ID to my device, and my device sends my device ID to your device. And say 5 days from today, I get tested positive, then I publish my, let's say, user ID or device ID, which is randomized, say, every day to a server, and you can query that server to see whether the user IDs that you've been close to have been tested positive. So I think this is a completely separate, architecture. I really like the model because it has really good privacy design. If you can randomize these user IDs well enough, no information really leaks. However, this is only useful for individual analysis, or letting individuals know after the fact. There is no location information tied. That's why the privacy is very strong. But also, this is not really helpful for, say, healthcare officials who want to respond to a high-risk area. Or this is not useful for me as an individual to take preemptive measures on deciding my routes, avoiding people with symptoms, etc. So it's a completely different approach. But I think what's important is it's important that big players like Google and Apple are coming into this market, because our approach focuses on location data. And if you think about location data already exists within big companies, big mobile apps, all that. And what we see right now is new applications coming up, and they're trying to get adoption. They're trying to get users to build data, etc. Whereas, if we're able to tap into these existing companies, like Foursquares, Yelps of this world, etc., then we already have this data, and then we can bootstrap it. So in that, I think it's a good call to action that big companies can think about, hey, can I let my user download their location data? Or can I let my user use their location data in a way that they can opt in to participate into this, COVID, I would say, tracing efforts.
So if we kind of build on that, we zoom up a bit, and Corona is just the live instance of this, where you have a Web2 approach and a Web3 approach. Are they distinctly different? Do you think these Web2 data platforms, data monopolies can transition into Web3, or is that impossible? Is it Web3 fundamentally different to the business model?
I think so. From a business model perspective, it's an interesting question. The way I see it is, I think these two worlds, at least from data side, will converge eventually, because if you look into Web3, it's all about self-sovereignty, giving users more control over things they do on the internet. And if you look into just the data aspect of Web2, especially with GDPR in Europe, technically speaking, I, as a user of an application or a product, I should be able to download whatever data I have. I mean, we're not there yet, but that's the direction that we want to head towards. So at that moment, if I'm able to use, say, Foursquare to, get my location data such that I can, use it for COVID or whatever purposes, as soon as I have access to that data, then I can use that data in the Web3 world. And that's where the Oracle come into play. I think the Chainlink is exploring some of these areas, but I think Web2 data will eventually make its way into Web3. It will be used for certain use cases, and it will provide value. For example, we can use identity in the Web3 world is a big issue. Right? How do you do identity? How do you verify people? All that. If you think of identity as different, let's say a large spectrum where one end is hey, I need my identity to vote, and then one end is hey, I need to prove that I'm not a robot, then I think using Web2 data solves a big portion of that spectrum where you can use your Facebook data, bring it into an algorithm that say runs in a privacy preserving network like Enigma. Based on that, we could determine you're not an actual bot, but a human being, and then issue a non-fungible. Then you can use that non-fungible to interact in the Web3 world. Obviously, this is not as safe as, hey, I'm Can Kisagun, I'm gonna vote in the next election. But there's a role for Web2 data.
And in addition to that, Enigma has a token. You've gone to great pains to bring that to market. Obviously, being predominantly based in the US, you've had to deal with the SEC and that kind of high level of regulatory oversight that's not necessarily present elsewhere. But you've still been insistent on the token being a fundamental part to the solution. Why is that? Why a token? Why is it's so critical that you would go through the pain of working and dealing with the SEC to try to bring that to market?
Yeah, so that was definitely a very tough process for us. And we're glad that it's behind us and we can focus on actually innovating in our space. I think a token, like when you look into a blockchain network where, there needs to be network participation, we're not talking about just an application. You kind of need to have a token or a coin that ensures that there are the right incentives for the network participants to act, how they should be acting. And that's like the broader theme of crypto, crypto economics. Because when you have I just gave you an example of us doing this work for COVID-19 in a non-blockchain setting. Setting up a server, say that's on IBM Cloud with the right trust model is very, very easy. What becomes hard is when you set that up and anyone who wishes to participate can participate in this network. Then attacks become more of an issue. You need to think about dishonest actors and how they can try to interfere with what you're trying to do. So in a world like that, the token creates an incentive such that, okay, I have a reason to act in an honest way because I will earn these tokens, and if I earn these tokens, that covers my opportunity cost, hopefully, of participating in this network. So to us,
a disincentive as well, right? So a cost to malicious behavior.
Exactly. If you're holding, within the proof of stake network, right? If you already have to hold a lot of these things to attack the network, then technically speaking, you attacking the network would be detrimental to you and to your holdings as well. So a token needs to exist if it's a network that is truly decentralized.
I don't know how much you can talk through this, but it would be good to understand how you manage that engagement with the SEC. I know you've now transitioned to Cosmos, and presumably the network it very deliberately has certain characteristics in its design and execution to allow you to have a functioning token. Can you talk us through the thinking there?
Sure. I think one thing that we learned after this, after this process is we need to be, very, very careful in the decisions that we make, and we need to make all decisions in a decentralized fashion. So, as you mentioned, we launched a Cosmos-based blockchain approximately around 2 months ago. The launch of the network happened with participation of over 20 different stakeholders, including Outlier Ventures. And the new network has a native coin that we call Secrets. Secret is, the governance, ensures governance of the Enigma blockchain. So all the governance decisions are made with secrets in a decentralized way. We have changed our role compared to I would say maybe 6 months or a year ago, where at this point we are a development team that builds new features for the blockchain based on what we see fit. But whether what we build gets implemented will be determined by the governance decisions that secret holders do. So at this point, we're just building and proposing, and any kind of execution of what we propose and adding this into the Enigma network is solely based on the discretion of secret holders. And other folks can also propose network improvements, and that can be voted upon. So I think what I'm trying to say is we have a much more decentralized approach than what we had 6 months ago. And we're just one of the many stakeholders in the ecosystem right now.
And it sounds like a logical pathway anyway, right? I mean, I imagine this is something that you were aspiring to realize anyway. It just so happens that perhaps it's had to be accelerated.
Yes. We always wanted to think about decentralized governance. I think 2 things have played into it. Obviously, us using Cosmos technology helped us implement this in a much faster way. And obviously, when you have major things going on, like force majeure, you have to reassess certain options and make decisions that are not only reactive, but also are for the better health of this project going forward.
So obviously in that use case, the Corona use case, you're talking about how individual citizens can share information. I know the Outlier Labs team have been working with you on how that could be extended to enterprise and corporations, working on something called the cross-enterprise collaborative analytics. Could you explain a little bit more about that?
Indeed. As we mentioned, the secure data sharing involves different parties sending data into the secure storage and computation platform. In the case of SafeTrace, it's patients, but also in the realm of enterprise, this could be different companies, this could be different business units. The work we've done actually was an inspiration for SafeTrace, where we create an environment for two telco players to share location data in a privacy preserving way, such that they could drive business insights as to where to build cell phone towers and for better coverage. We also see this use case being or this technology being very relevant to solving issues around frauds, whether it's user fraud or driver fraud in the share ride economy and the delivery economy. So this is a very promising area.
Yeah, well, look, thanks so much for your time. We'll have to wrap up there. I know the Outlier Ventures Labs team have been doing some work with you on something that's called the cross-enterprise collaborative analytics, which was again around data sharing. So people should check that out. But I think it's going to be really interesting watching this pathway to decentralization, increasingly having roadmap both informed and potentially even executed on by the wider community. So thanks so much for sharing your journey with us, and good luck.
Thanks, Jamie. It was a pleasure to be on your podcast.
If you enjoyed today's podcast, please make sure you subscribe, rate, and share your feedback to help us reach as many people as possible with the important mission of Web3.